graph of the inverse function. Consider the graph of f of x equals square root of x minus 2 and f of x equals x squared plus 2 for x greater than or equal to 0. So let's start with the graph of f of x equal to square root of x minus 2. So this graph is moving 2 units to the right compared to the graph of square root of x. So this looks like this is f of x. So the next one is g of x equal to x squared plus 2. So this moving 2 units up compared to the graph of f of x. Moving 2 units up compared to the graph of x squared. And here we want x to be greater than or equal to 0. So this is what the graph looks like. So note that the graph of f of x and g of x is symmetric with respect to the line y equal x. Okay. Now it makes sense because the domain of f is now the rank of f inverse and the rank of f is now the domain of f inverse. So the graph of f and f inverse is symmetric with respect to the line y equals x. Right? So let's take a look at the next problem. So graph f of x for x is greater than 0. So this graph is kind of out of our range with the coordinate that we have. So let's change our question. Let's give an f of x equal 3 minus x squared for x is greater than 0. So we can graph f of x. So f of x is moving 3 units up and flip over the x-axis compared to the graph of x squared. Okay. And we only want to graph the part where x is greater than 0. That's why, so because we restricted the domain like this, we have a one-to-one function, so then we can have the inverse. So this is f of x. We want to use the graph of f of x to get the graph of f inverse of x. So since it is symmetric with respect to the line y equal x. So let's do this labeling here. So this point have the value of 0, 3. This point have the value of 1, 2. And this here is 2, negative 1. To graph that, so we need to find the point on with the graph of f inverse of x. We start with 3, 0, 2, 1, and negative 1, 2. Okay, so 3, 0, 2, 1, and negative 1, 2. So this is the graph of f inverse of x. Let's find f inverse of x algebraically. First, we will solve for x in the equation. So x equals square root of 3 minus y. And because x is greater than 0, so we don't have to worry about the plus or minus. So then y equals square root 3 minus x, and this is our f inverse of x is equal to square root of 3 minus x. And it's consistent with the graph that we created. Given the function that is not one-to-one, restrict the domain so that the resulting function is one-to-one. Find the inverse of the function with the restricted domain, then sketch the restricted function and its inverse on the same coordinate plane. Okay, so I know that the graph of absolute value of x. So the graph of the absolute value of x is gonna look like this, a V shape on both ends. Okay, so here this part when x is less than 0 and x is greater than 0. So we can restrict the domain to either one of those parts. So then there can be two different answers here. So what I do is I would restrict the domain where x is greater than to 0. So if I want to restrict the domain to the right range of the graph, then I would restrict the domain where x minus 3 is greater than or equal to 0. This telling me x is greater than 3. So because of restricting the domain like this, the function f of x equal to absolute value of x minus 3 is now a one-to-one function. Okay, so f of x is now a one-to-one function. Let's find the inverse of it. So y equal absolute value of x minus 3, and I want to solve for x. So then y equal to x minus 3, because we restricted it to the part where it is greater than 0. So now we switch the x and y. So then the inverse is f inverse of x is equal to x plus 3. Okay. So let's graph the inverse and the absolute value function on the same xy coordinate plane. So f of x equal to x minus absolute value of x minus 3. The graph is moved to the right 3 unit compared to the graph of f inverse of x. So this is what we get. So this is f of x. And f inverse of x is the line where x is at that x plus 3. So this is the line that moving up 3 unit from the line of y equal x. So then this is f inverse of x. And note that this both line is symmetric with respect to the line y equal f of x. Y equal x. Let's take a look at this couple application problem. A painter charged a flat fee of $50 plus $25 per hour for his service. Write a function f that represents the cost of service x hour. Then f of x is equal to flat rate plus $25 per hour. Let's find the cost of 10 hours of service, which means f of 10 is equal to 50 plus 25 times 10, and that is 50 plus 250 equals $300. Okay. F inverse of x is equal, the next thing we do is to find F inverse of x. To do that, y equals 50 plus 25x So F inverse of x is equal to F inverse of x is the amount of hours for x amount of money. Let's take a look at the relationship between Fahrenheit and Celsius scale. So is it given that the Fahrenheit equal to G of C, that is 9/5 times C plus 32. Let's find G inverse. So F is equal to 9/5C plus 32. So this is the G inverse. So G inverse is the equivalent temperature in Celsius. Okay, so G inverse of 86, that is equal to and this is 30 degrees in Celsius.